Let's take a closer look at the warm-up from today. I'm going to call this function out here, f of x equals 1 over x. This is what we call a parent function. The purpose of the warm-up was to move this along this slider and watch how the n value changes. You can see the effect here on this 1. You can also see the effect on these ordered pairs. So let's take a look. What's happening? We know that the value or the coefficient here is changing, and we also know that these ordered pairs are changing. It may appear the function is getting further from the origin, but that's not actually the case. I'm going to change it to n. I am multiplying 8 times the parent function of 1 over x. What I notice here is that the x-coordinate is not changing, but the y-coordinate is. The y-coordinate is moving vertically. We call this a vertical dilation. Next, I'm going to take this parent function of 1 over x and I'm going to multiply by 4. So what happens when I multiply by 4? I can see along my graph that each of these values, or ordered pairs, are being multiplied by 4. This was 1/2, comma 2, and this has now become 1/2, comma 8. This was the ordered pair 1, comma 1, and now it's 1, comma 4. When I look at my table of values over here, I can see that each of the values have been multiplied by 4 to give me the new value for g of x. I can look at this as a vertical dilation by a factor of 4. We call that a stretch. I'm going to go back to my parent function just to clear the graph. And this time I'm going to look at 1/4 times 1 over x. So what happens here? I can see in my graph that instead of the ordered pair 1/2, 2, I now have 1/2, 1/2. Instead of the ordered pair 1, 1, I now have 1, 1/4. Does that correspond to my information here? Yes, I can see here that I have -1 times 1/4 equals -25 hundredths. And for each of these, I can see that the numbers are being multiplied by 1/4. We call this a vertical dilation by a factor of 1/4. It's a shrink or maybe a reduction. I'm going to bring all 3 graphs to the same ordered pair. I have x values, my f of x, g of x, and j of x, and they're all graphed here. I want to show one quick thing. I can also look at g of x, 4 times 1/4, as 4 divided by x. This coefficient here goes to the numerator. When I would multiply by 1/4, I'm going to write this as 1 over 4x. The graphs look the same, and the table of values are the same. 4 times 1 over x is indeed the same as 4 over x if I look at my table of values here. 1/4 times 1 over x is the same as 1 divided by 4x, and I can see that through my table of values.